Um, so Apache Camel. Obviously, you're all here because you're interested in Apache Camel. What is Apache Camel? Apache Camel is making a lot of noise out there right now. It is a lightweight integration framework. Some of the things it can do is just amazing. It can literally cut out code and get rid of plumbing for what you normally do. If you need to read a file out of the directory and have it sent somewhere, normally you'll have to put that stuff up. With Camel, you just set up a URI, you point towards it, boom, you're ready to go. I'll show about how that works in a little while. The nice thing is, it's all based on standards. There's just a tremendous amount of components that are out there, and what's cool about it is it's all open source. None of the stuff is proprietary. This thing goes circles around other APIs and other frameworks that are out there. The nice thing about Camel is it's based on EIPs, Enterprise Integration Patterns. Who's heard of EIPs? Good. For those of you who haven't heard about it, basically it's certain patterns that we do every day when we're developing software. Now, a lot of these patterns kind of mimic themselves over and over, and these come up with these patterns. There's some really good websites out there that cover enterprise integration patterns. If you Google it, you'll find it. But basically, EIPs are kind of like what you see here. It's just, it's made up of splitters, aggregators, wiretaps. These are all kind of like buzzwords. And if you go out to some of these websites, or even to the Apache Camel website, you'll kind of see how some of those work. This is kind of like what an EIP flowchart will look like. You'll put something like that together as you're developing software, say in your architectural documents, to say, this is what we're going to do. The nice thing about Apache Camel is it has a whole bunch of components. In fact, last count, and I counted it, I actually hand counted it this morning because it continually grows. There's 183 different endpoints and components that you can reuse. For example, JMS, JMX, file component. The JMS you can read and write from different queues or topics. File component, reading and writing from different directories. There's even Google Drive endpoints that'll connect to a Google Drive and read files out of that. And it's just a matter of setting these endpoints up and configuring them. HTTP endpoint, you can actually create RESTful services off of that, or even a web app. And that kind of goes back to the basis of microservices, where you can use a Camel route to be a web application in and of itself. Without a war, it's just a route. And it's kind of neat how this stuff works. Endpoints like CXF that handle SOAP or JAX-RS calls, RESTful calls. If you go to this link here, the Chrome's link, you can see what's out there. It's amazing. Apache Camel is really based on what we call domain-specific language. Domain-specific language is like, it basically takes a language and it makes another almost syntax out of it. You'll notice, for example, when we're writing in Java, we'll have, up here, going from, we'll wiretap it, and then we'll go to somewhere. So always in Camel, you're reading from something, you're consuming something, and then you're sending it to something. That is what makes it a route, or a group of routes. You can continue adding tubes on there and then have it go to another place, and then another route can pick up and run with it from that point forward. We can also do it in XML. If you take a look kind of what we did in Java, in XML and Spring, all right, or in Blueprint, we'd have something very similar. There's our route. It's almost identical. And of course, we'd have it in Scala as well. So you kind of have your choice on how you want to put this stuff together. How do we deploy Camel? Camel's really an API. It's a micro-container, but it's also an API. We can deploy it inside of, we can run it standalone. We can deploy it inside of web containers. We can put it in application servers, OSGI, Carafe, and believe it or not, you can actually embed it inside of ActiveMQ. So we've seen that being done. I've seen some folks take ActiveMQ and actually build a full Camel application underneath it, and you're like, no, you got it backwards, go the other way. But it's good news if you need to route stuff very quickly between queues. You can do that very quickly inside of ActiveMQ or some type of queue. What is so cool about Camel? What does it do? When I have to read from a queue, I have to write a lot of plumbing code, right? I got to set it up, get the destination, that sort of stuff. All this code can be funneled down to this. That's it. That's all you got to do. You set up basically your connection factors and that thing in some XML code, and bam, you're instantly off to the races. Camel, as I said before, is a container in and of itself, and it's all wrapped in what we call the Camel context. And typically when you're writing stuff in a web, say in Tomcat or running something on its own, you're going to use it, you'll pretty much use a single Camel context. But when you're using something like Carafe and might be deploying bundles as applications, you might have many different contexts. So in this situation, we kind of show how we would go about deploying a Camel context. One of the things to note is your Camel context is then made up of routes. You could have one-to-n routes inside your Camel context. So there's just a multitude of different ways that you can deploy Camel. If we use Spring, initializing Camel context is really simple. And 99% of the time, this is kind of what we'll do. We'll do this in Spring or in Blueprint, where you will create, you basically declare a Camel context, and then you put your routes inside. Okay? And you'll have the multiple routes, route 1, route 2, route 3. It's that simple. That's it. It's that simple. So when we do route things in Camel, we route them via messages. So the basic area or the basic object that we push data through or push information through Camel is basically a message. It looks very similar to a JMS message, right? The message has headers, it may have attachments, and it has a body. A lot of times, most of the time, you'll be working with the headers and the body. Okay? Now that message, you're not just dealing with a single message there. What actually goes through the entire route is what we call an exchange. It's very similar to SOAP. It's a wrapper. It's an envelope wrapper. And inside that message, inside that exchange, we have basically the exchange ID that identifies what exchange it is, some properties. We can actually set properties at the exchange level. Any exceptions that occurred. So if you throw an exception, this thing will pass the exception all the way back. And so you have something to be able to work with. And then we have what we call a BEP, which is a message exchange path. And I'll explain those in a minute. Basically, it tells what is the context of this exchange. Is it in only or is it in out? In other words, is it synchronous or is it asynchronous? And I'll show you that in just a moment. Then every exchange always has two messages. It has an in and an out. Okay? The in, which I'll show in a moment, kind of goes through and is updated as it goes through the route. And when we're ready to return, the out set and it goes all the way back. Also, if you guys got any questions, let me know. Feel free to raise your hand. If I'm going way too fast, let me know. I wanted to get in the code because all this really comes together when we get into it, which is the cool part. So here's kind of how the exchange is used, right? I just showed you what an exchange was. So typically, the consumer will create the exchange and wrap what you're sending it to. In other words, if you're picking up a file, it'll take your file contents. It'll basically create the exchange, and it sets the in, and it starts moving through the different processors to be able to change the body as I move through them. So the consumer can create it, or you can actually create it externally and send an exchange in directly if you wanted to. We call that setting what's called a producer template, but that's above and beyond this discussion. And what we do is, as the exchange goes through there, the in message is typically modified by each process in the route. So what you don't want to do is say, hey, I'm going to update the in and then I'm going to set the out so it goes on to the next processor. If you do that, you blow up. Your route basically says, oh, it looks like he's done. I'm going to send it and get it out of here. So typically you want it'll nullify it. So you typically want to edit the in as it goes all the way through the processor until it gets to the very end. Now, if you're doing an in-out, at the very end, you want to set the out, and that way it goes all the way back to the consumer, and it gives the out is basically the response. So that's how the exchange is used. But always keep in mind that it's very important to understand, don't set the out through each processor. You want to do that at the end. Okay? Otherwise, it actually gets nulled out as it goes along, and you end up losing stuff, and you end up with empty stuff. The message exchange pattern, or the MET. So there's two types. We have in only and in out. In only means you're dumping something off, and you basically don't want a response from it. You're getting rid of it, and you're letting the system run with it. It's asynchronous because it continues its processing, and the consumer can go away at that point. Consumer doesn't need to hang around waiting for anything. That's good for like file drop-offs, stuff like that. That might be a good place for using an in only. Like the file component is probably a good one that would do that. Then we have in-out. In-out is going to be synchronous, all right? For example, if we're using a web call, say a JAX-RS call or a SOAP call or something like that, obviously we want to wait for some form of a response. So we have an in-out exchange that goes through, and the consumer's going to be waiting until the producer is done, sets the out, sends it back. Now, we can also be asynchronous. I hate to say that the whole thing is synchronous. We can also be asynchronous, for example, when we go to JMS or when we go to setup endpoint. What the JMS will do is, in order to get a response back and forth, the Camel component actually creates temporary queues behind the scenes to set up a request reply. You don't have to do any of that stuff. That's done automatically. So the bottom line part of what we do with Camel, as we're doing routes, is we're just wiring together processors, endpoints, and components. That's all we're doing. It's really kind of simple. Typically, when you're writing a route, you usually will have a consumer endpoint, something you're reading from. So you usually have the route will say from some form of URI, and we use URIs. Okay, URI kind of defines what component you're using. It could be JMS. It could be something that you wrote yourself. We'll see some of that. And then you're going to produce it. When you send it to something, you're going to a producer endpoint. And I just kind of showed that. I showed you before the XML. This is kind of like what Java would look like. When you're using a Java API inside of a route builder, you would say, it's kind of neat to use this, especially in an IDE, because as you do the from, the twos will pop up if you're using an IDE that tells you what's next. And we can actually directly call some of the EIPs, right? They're actually implemented as processors. For example, the splitter. We need to split something off. So we can split it either like in an Xcode here, actually in a route, or we can write a splitter ourselves. And how do we write our own stuff? We basically use what's called a processor. All right. Camel has a processor interface that you can implement that basically takes in an exchange, and in your exchange you'll be able to mess with the messages. So I would say exchange.getIn, get me the in message, I have the in, and then I can set the body. That's how easy it is. And you'll actually create your own URIs and your own components through using those custom processors. And as you're developing, there's the Maven Camel Run plugin that we use. We use that so you can actually launch and test your Camel routes as you're using Maven and as you're going through your software development cycle. It's just fantastic. So with that, let's do some live coding. All right. So what I have here is I've got basically an empty project. Here's my POM file. I call it Camel Writer. I've got all my dependencies in here, kind of your standard Maven stuff. I'm sure most of you use Maven. And I also have here my Camel Maven plugin. Pretty simple stuff, standard stuff, right? Are most people familiar with Maven? Yeah? Then I have here an empty Spring, I called it Camel.xml, sitting in my meta Spring directory. That's typically where we like that stuff to be picked up for Camel. Okay, and so it's empty. So we want to build something. So we want to build something. What do we want to build? Let's take a look. We've got a company. Our company is called Widgets.com. We just got hired to be able to start building out their APIs. Basically, a consumer goes to the website, they want to order something, they create what's called an order. So we all know what an order is made up of, right? It's got a name and it's got line items of things that we're ordering. It basically goes to our Widgets.com servers. There's some kind of a service running there. And then, of course, we have to get those widgets individually from the different manufacturers shipped directly to the end users, kind of like Amazon.com, right? We order a whole bunch of stuff and you start getting all these shipping notifications because it can come from different centers, different manufacturers, and that sort of thing. That's what we need to build here. So, first thing is, what is an order? An order basically is made up of customer, their address, city, state, that sort of thing, and then a whole bunch of items. Multiple items. We've got a list of items, and it's the name of the product and the quantity. So, let's start off actually what we're going to build first. So we need to start creating the domain, which is going to be our order, right? And we're going to build this. This is the first part of what we're building. We've got a requester. We've got a JSON order that's going to come inbound. We've got a RESTful JSON service. We're going to have that service go inbound, and then we're going to send some form of a JSON response back, right? So that's what we're going to start with. So we're going to start with our domain. So first thing, we're going to create our customer. And I cheated on this to make it go quickly. Yeah, I'm a quick gooder. And these are already annotated up using JAXB, all right? Because I want to leverage some of the cool stuff that CXF gives me as far as JSON is concerned. So I've got my customer with my setters and getters. And again, if I'm going too fast, feel free to stop me. Then we have the concept of an item, right? So there's our item. Our item basically is a product and a quantity in all my setters and getters. Now let's put that together and create our order. So our order is made up of a customer, and then we have an array list of our items. Pretty simple stuff, right? And then finally, so now we've got the concept of an order, we need the concept of what we're going to respond. So we respond with an order response. So here's my order response. Basically, order response comes back as status. Everything's okay. Hopefully, who knows? Now, let's start putting together the endpoint for CXF. So we want to create a resource file to be able to do JAX-RS. So we're going to create an orders resource interface. Okay. Now, for those of you who here has used JAX-RS, good group of folks. So for those who don't know, basically we declare that our path order is going to take a post with add, and it's going to produce and consume JSON, and it's basically going to call add order. Okay. Pretty easy stuff. This basically declares everything and sets it up. Okay. So now that we've got an order resource, we need to also come up with how we're going to answer stuff. So we're going to put together the JSON response processor, and this is going to be a Camel processor that I kind of showed earlier on what we'll do with an exchange. And it's pretty easy stuff. So basically, our JSON response handler, we're going to take an exchange in, we get our order response, we're creating an order response, we're setting that, and basically we're setting that out as the body. That's it, okay? Because this is the end of this particular route, so I can do the get out, because that's the response I want to come back. So let's wire this all together. So the first thing I want to do is set up my CXF stuff. So basically, I'm taking my JSON response processor with what I just created. I'm setting up what's called the JSON provider. This is kind of some boilerplate stuff we have to do for CXF to say, hey, I want JSON to be coming back to me. I want to be shaking hands with that. And I want to be listening on localhost 9090/rest as my my service, and it's utilizing my order response orders resource that I had put together here. Okay. And this is an endpoint. This is a CXF RS server endpoint in Camel is what I'm using. So I'm just wiring that stuff together. So let's set up our Camel context. So here's going to be our first the demo guys are with me today.
Your intelligent mess up. You change the first tag beans. The Camel.
Oh, there it is. Ha! Thank you. The intelligent got me. Thank you. Good eye. All right. So this is our initial route. So basically, I've set up my Camel context. I'm going from the order service, which is our JAX RS service, and then we're going to the order response processor for response, right? Simple stuff, let's see how it works. Let's take a look. So what I'm going to do is use the Maven run. Go ahead and set that up. And as you can see, we're now listening on localhost 9090/rest. So let's see if we've got a service running. Let's see if we got a waddle. Hey, we got a waddle. Fantastic. Let's take a look and see if that's in JSON too. All right, looks good. So we're getting a waddle that's coming back both in JSON and in XML. So you saw how easy that was. That was just a minor amount of code and some wiring together. That was pretty good. So let's send it some JSON and see what happens. All right, so I have some JSON here. Customer, Mr. Heath Hessla from Jackson Hole, Wyoming. He purchased 2 widgets from the ABC company and from the XYZ company. And let's go ahead and send this. So we're doing a post. We're going to a REST order add. Remember, we set all that stuff up. So let's go ahead and send it, see what happens. Hey, we got an order response. Thank you for your order. Wired that up, got a response. Looks good, huh? All right, big deal. Doesn't do it too much, does it? Huh? Right? So let's make it do something. So at this stage, what we want to do is we want to add in some EIP. We're going to add in what's called a wiretap, and we're going to throw ActiveMQ in there. Because what we want to do now is we're going to a RESTful service, basically did all the marshalling, or unmarshalling, and everything went over to it, took the JSON order, turned it into Java objects, JSON response processor went back. What we want to do is inject in there a wiretap to send it on to ActiveMQ. Now, just as a side note, if I'm doing any type of verification of my data, I want to do that before the wiretap because I can always stop and do a response at that point by sending the out and telling the Camel stop and forcing the response to come back and say, hey, illegal parameters, you can't do this. But to make this really quick and dirty, we're gonna stick the wiretap in there, and then the JSON response processor just is sending back what we're doing. The wiretap is going to send it to an ActiveMQ queue, and we're going to be sure that it is fully persistent. We don't want to lose the message, right? The message comes in, we don't want to lose that order. The guy already paid for it, we don't want to lose it, so we're going to send it to ActiveMQ. Also, from this point forward, we're going to be using the shorthand notation instead of all this stuff. We use the shorthand to save space. Okay, so let's go ahead and add in wiretap. So the first thing we want to do is let's go ahead and launch ActiveMQ. And then let's go back to our code. So we want to add in there the wiretap. Okay, so first thing to do is now that we're running ActiveMQ, let's just go take a look at our ActiveMQ console. Let's take a look at our queues. Right now we've got no queues, okay? Empty, no queues. So, we're going to go ahead and add in a wiretap at this stage. But before we do that, let's set up ActiveMQ. So, okay, so here's what we're doing with ActiveMQ. So what we're basically is we're setting up a connection factory, okay? We're setting up a pooled factory, all right? So we have a normal factory and a pooled factory, and then we also have a consumer and a producer JMS configuration. And whenever you do anything with JMS, always have a consumer and a producer connection factory, because the reason is producers you want to pool, consumers you can't pool. You just reuse the connections. It's very important to do that, because if you try to pool consumer connections, you're going to run into big problems. So what we're doing is we're creating a JMS configuration from Camel. We're setting up here the AMQ connection factories, and then the pooled connection factory, and then we're creating, these become our endpoints, our JMS consumer and our JMS producer. Okay, so now that we've got these components, we can use these in the URI. So let's go ahead and add the wiretap. So I've added the wiretap. I'm pulling in my JAX-RS. Before I go and I do the response, I'm basically persisting my message and I'm sending it to the orders queue. All right? So I'm using my JMS producer because I'm writing to ActiveMQ. Okay? So let's go ahead and see how that works. Let's come back here and let's verify our queues. Notice nothing's there. Let's go ahead and send. I think it's sent. Take a look at our queues. And there it is. So I have written one message to the queue. So in queue one message, there is one message sitting on there. All right? That's my order. My order is actually sitting on there. Okay, that's great. So what are we going to do next? Well, now what we need to do is do something with it, right? So now we're going to write a second route. The second route, we basically want to inject in there to read the order off the queue. If you take a look at Route 2, we did Route 1, we're now in Route 2, we're going to read the order off the queue, then we're going to split it up. Remember, there were two. There was an ABC widget with 2 quantity there, and then an XYZ with 1 in there, or I don't recall what the quantities were. We're going to split that up. We're going to take we're going to split this up into individual product orders, and then we're going to send it to a content-based router that says, I'm sending it to this ABC's queue, where he can pick up his individual orders, and I'm going to send to XYZ's queue where he gets his. We don't want to mix those up. We want to be sure we're splitting those up. Okay? So, let's go ahead and do that. Actually, before I do that, this is what we're doing. So we're now converting our order into individual product orders, all right? And all the manufacturer cares about is his customer and his product and quantity. He doesn't want to see all the other crap. He doesn't care about XYZ, doesn't care about ABC. ABC doesn't care about XYZ. So let's go ahead and code that up. Okay, so the first thing that we're going to do is we're going to go to the domain and we're going to create the concept of a product order. So here's our new domain object. There it is. Pretty simple stuff, right? Customer, product, quantity. That's it. Pretty simple stuff. And now we're going to write our splitter. So this is a very specific type of splitter that we're coding up. Some of this stuff you can do in XPath and just do it in a script. We're actually going to write a little bit of code, and you'll see why. Okay, so here's our product splitter. So our product splitter, it's kind of cool. It takes the order indirectly, and what we want to do is return a list of Camel messages. All right? So I've got a single order that comes in. I'm creating an array list of messages, and then I'm going to iterate through each one of my items in my order. For each item I get, I create a product order. I set the customer, I set the product, I set the quantity. Then I create the message, a Camel message through a default message, and I set the body, I set the product order into the body, okay? The other thing I do is I'm setting a header. I want to set a header to be able to allow it to filter when I go through a content-based route. So here, just kind of showing you, I just take my message and I say, if the product starts with ABC, I'll set the header as manufacturer ABC, and if it's XYZ, I set it as XYZ. So now I've got a header, okay? Then I basically add the message to my array list, and when I'm done, the array list goes up. That's my split. That's it. Let's take a look and see what this is. All right, so route number 2 is reading from my orders queue. Remember, we already have something sitting in there. And now we're going to call our product splitter, and we're calling split products, which was our method, split products, right? And it automatically knows that it's a type order because that's its payload. I don't have to do anything else. When I'm done with this, splitting the products up, I'm going to set it into what's called a content-based router, which is a choice. And I basically, remember I set the header before? Here's where we're going to test it in some script code, some OGNL. I take the in header manufacturer. If it equals ABC, I'm going to send it to another queue, ABC company. If it's XYZ, I'm sending it to the XYZ company. If it doesn't match any of these, it's going to the no idea queue. Okay? So let's just take a look real quickly. Let's verify. Let's look at the queues. Right now, I only have the orders queue. So now, because I added a new order, I don't need to resubmit, because it's sitting in my queue. It's persistent. I have not lost the message, all right? So as soon as I run this route, that route number 2 is going to pick up, and instantly it's going to throw it to the other to the other queues. So here it goes. Route started. Let's take a look and see what we got. Hey, there we go. XYZ company has one, and our ABC company has one. Great. Okay. Our widgets.com, we've kind of done everything that we need to do from that perspective, but we need to do something else. Oh, by the way, I should have showed this. This is what we did. The code we just wrote. This is the shorthand for what we did. Sorry about that. This is what we did. Here's our content-based router, and basically we threw it into our ABC XYZ queues, and now what we're going to be moving towards is the manufacturer processing. Now widgets.com is done. Now each manufacturer has to do something. Okay, so now each manufacturer needs to read their product orders. Okay, it basically needs to take those Java objects, it needs to marshal them back to JSON, and then it's then in a product order JSON type of format, and then we're going to use the file endpoint to dump them out into the specific order files for the specific companies. So let's go ahead and do that. All right, so this is ABC company's route, this is XYZ company's route, right? We're going from ABC or whatever the company is to, we're basically saying marshal it, change it over from a Java object into a JSON library, then send it to a file. And the file is going to be in my target directory down here. It's going to be created in a manufacturer's directory, and ABC has his own directory, XYZ has his own directory. It's got an order, month, date, year, time, whatever, put onto it. Okay? So, before we start this, let's verify. XYZ and ABC still each have their own messages pending. What do you think is going to happen when I run this? Let's see. Let's hope. We'll see if the demigods are with me, right? Okay, so that's done. Let's take a look and see what happened here. Let's look at the queues. Oh, look at that. It got cleared out. Messages got read off. They went somewhere. Also, look at this number of consumers. I set up in my consumer, I set up 5 concurrent consumers. I don't know if anyone noticed that in the Camel code. Look how many consumers I have on it. Pretty cool. And that allows for multi-threaded processing for very high transaction loads. So one message enqueued, one message dequeued all the way across. In theory, we should have something in here, right? Let's take a look. Oh, there it is. Manufacturers, ABC, XYZ. They each have an order. And look at that. There's my order. Mr. Heath Hessel is getting an ABC. And he's getting XYZ from these 2 manufacturers. Okay? Now, let's see, let's put it all together. Let's see if it works, right? In theory, this should go all the way through. If I submit this, I should end up with a second set of orders immediately, right? Everything's going to be put together at this stage. Ready? Thank you for your order. Nothing in the queues. There's my orders. Second set of orders. Pretty cool. That's everything together. Let's go ahead and let's put an item that's no good in there. Actually, let's do 5. Let's do 2 ABC widgets. And we've got our bad widget. Okay. What do you think is going to happen before I go ahead and execute that? Say that again. Correct. And he's probably going to get stuck in there, right? And then how many, I'm going to clear this out. I'm going to clear out our manufacturers. So by looking at this, we're probably going to get 2 orders in the ABC. XYZ will have 1, and the bad widget should go to the no idea queue, right? Come on, demo that. Thank you for your order. Let's take a look and see what's in the queue. Hey, we got a no idea. So now, someone from widgets.com will read that and go, how the heck did this get in here? And let's take a look and see what happened. Look at that. Exactly what we thought. There's one with 2. There's one with 5. There's one with 4. Pretty cool. Notice, there really wasn't a lot of code in here. A lot of this was just wiring endpoints together. That's really all I was doing. One thing I really want to point out here about these routes is these can be deployed on multiple machines. This does not have to be a one Camel route. These are microservices. This is the basis of microservices. And Heath's going to talk about that a little later today in his session. These are microservices. These are particular endpoints that you can put anywhere on any container, and it will do the same thing. It will still write to ActiveMQ, it will still answer the JSON queries, and it will still create the file somewhere for the manufacturers to pull up. And if you notice, the reason why I put the head of each manufacturer to do a route is these could live at the manufacturing companies to be able to pull stuff off their queues over the wire and start a production run at their own facilities. So this could completely be distributed no matter what, which is pretty cool stuff. So, questions? Yes?
So, in your example, you're doing some processing, you've got entities and stuff tied in, you're deploying the Camel human record. So if I'm using something like, say, Python or something, am I going to find this thing to be that useful if I'm running Camel Heart standalone, or how does it interact with it?
So what do you mean by you're running Python?
Let's say that my order application is in Python.
Okay.
I still need to process it, an order, I still need to
right.
get it off, and I still want that decoupling that you
Yes.
Can I use Camel standalone and interact with it?
Absolutely. Absolutely you can do that. So something you can do, you can take your Python application, use a stop connector, write it to ActiveMQ, then have your Camel application read off of the queue and pick it up. And now you've pieced everything together.
Okay, yes, okay, that's exactly what I did.
That's the nice thing is you can do crazy stuff with this. And I mean crazy stuff. There's 183 different endpoints. I mean, you wouldn't believe. I mean, you could have your Python stuff write something to a Google Drive and have Cal just pull it off Google Drive. I mean, it's cool. The stuff is cool. It's amazing. And when you start taking that as a component and start putting it in Carafe, and you're utilizing ActiveMQ or RabbitMQ or whatever type of queue system you're using up there, now you've made a huge cloud-based system. And that's really why I wanted to show what we did here is that right there is the basis of an API that's cloud-based by using just the components that it. Granted, you'll want to throw in transactions and that sort of stuff to make it more robust and check stuff, but that's usable code to start some form of a project to be able to do that sort of thing. The cool thing about it is just seeing how lack of little code, and that's why I had that slide before that showed, if you're going to do JMS, that's what you got to do.